are the pi model and T model. So don't waste time here. Let us go with the transistor model. Here, this is the introduction. AC analysis of an transistor can be carried by drawing its AC equivalent circuit. After this AC equivalent circuit, you can plot or convert it into the models. So there are basically two different types of models. Number one is pi model and number two is T model. So here we are going to discuss pi model and T model. So let us start with the T model. One of the oldest AC model which is look like alphabet T, so it is known as T model. For small AC signals applied to the input, the emitter diode of the transistor is equivalent to the resistors RE dash, and the collector diode is equivalent to the current source IC. That means here AC signal analysis, we have to transform it into RE dash. Here we can see it RE dash, and other sources is converted into IC. Here we can see this is the current source which is converted into IC. Basically T model, that means if you are transform your NPN transistor into the model which is becomes T model. Here we can see this is the NPN transistor symbol or construction which is converted into this T model. So we have to transform this transistor into this equivalent circuit, that becomes T model analysis, or we can say this is the AC analysis. So basically this chapter is based on AC analysis and small signal amplifier. So here through this we can analysis the T model. Now here this is the second type of model which is known as pi model. Here we are also used for the AC analysis of the transistor. For this model, the input impedance measured at the base terminal. Here we can see base terminal is for the input, and here ammeter is for the output side. So we can use both model for analysis, but most of the time pi model is preferred than the T model because it is easier than the T model. That's why we are prefer pi model instead of T model. So through this T and pi model we can analysis the AC circuit. How we can analyze the AC circuit? So here we can see from this figure, that is your circuit diagram which is base biased amplifier. If this is the DC analysis, then we have to remove all capacitors from that circuit diagram because capacitor blocks DC and it becomes open circuited. That's why here we can see it becomes open circuited, so there is no capacitor in this circuit diagram. So basically this is the DC equivalent circuit of that amplifier. Now here below we can see this is the AC equivalent circuit. How we can draw this type of equivalent circuit from that main circuit? So that is your AC analysis. So this is the AC equivalent circuit. Basically it comes from that main circuit. So for that we have to plot, instead of NPN transistor, one pi model or T model. So here we can see this is the pi model instead of NPN transistor. So let us start with the input side. From input side, so there is a one Vs which is source voltage. So here we connected Vs source voltage. Now there is a one capacitor which becomes short circuited because here we are going to use AC analysis. So always remember this thing, capacitor blocks DC signal and it allows AC signal. So this is the AC analysis circuit, that's why it becomes short circuited. Now here remember this, there is a RB So RB is connected here, which is exactly parallel to the VS, right? Because there is a node which is divided into two parts. That's why it becomes parallel. Now, I already told you that instead of NPN transistor, we have to put pi model or P model. So here this is the pi model. So what is the equivalent of pi model? Here we can see this is the pi model. Here base, below emitter, and here collector. We have to put beta RE dash resistor. Here this is the emitter, and here this is the source, which is current source, which is known as IC. These all things put instead of this transistor. Here we can see this is the beta RP dash, here emitter, and here IC. So this is the pi model instead of NPN transistor. Now remaining components RC and RL. Between RC and RL there is a one capacitor which is C2, which becomes short circuited. That's why here RC and RL becomes parallel with each other. So RC and RL, which is parallel with each other, and here this is the output side, we can say output voltage. So like this we can convert AC equivalent circuit with the help of pi model from main circuit diagram. So this is the one type of conversion. Here we can see this is the VDB amplifier. So why we are going to use VDB? We already discussed earlier chapter. VDB, that means it is voltage divider bias. Voltage divider bias is the perfect stable circuit. That's why we prefer for amplification. So in all CE, CC and CB amplifier circuit, we are used only VDB circuit. So what is the difference between the other circuit and VDB circuit? So here we can see R1 and R2 parallel with each other. That means here this is the VDB circuit. Right? Remember this thing. And here RE resistor, and across this RE there is a one capacitor which is known as bypass capacitor. We already discussed in lecture number 1. So here we can see this is the circuit diagram, that is main circuit diagram, and here we can see this is the DC equivalent circuit. So DC equivalent, that means we have to remove all capacitor from this circuit diagram, so that becomes DC equivalent circuit. And below here we can see this is the AC equivalent circuit. Now what happened in AC equivalent circuit? Here first we are going to start with VS, then after C1 is short circuited because of AC analysis, then R1 and R2 which is parallel with each other. So here we can see this is the R1 parallel R2. Then instead of this NPN transistor we have to put pi model. So that is a one resistor beta RB dash, then one source which is current source, which is going down, because here we can see collector current flows downward direction. That's why its direction is downward direction. So IC and 1, and what remains RC and RL. So RC and RL becomes parallel with each other due to C2 is shorted. So here we can see RC parallel RL, and after that output voltage VO. So this is the AC equivalent circuit, and from this circuit we have to measure, we have to derive voltage gain, input resistance, output resistance, and then we will get amplified output. And these characteristics we have discussed in lecture number 1. Main characteristics are: number 1, voltage gain. Gain, that means it is the output upon input. Number 2, input resistance. It always find across the input side. And output resistance, it always find across this output side. So let us start with first circuit amplification, CE amplifier. CE stands for common emitter amplifier. So here you can see this is the CE amplifier circuit diagram, and below this is the AC equivalent circuit, and below AC equivalent circuit by using pi model. So AC equivalent circuit, that means we remove all types of capacitors from this main circuit diagram. That becomes AC equivalent circuit. And here this is the pi model AC equivalent circuit. That means we have to put pi model instead of NPN transistor. So this is the common emitter amplifier. And in this theory we have to find three characteristics. Number one, voltage gain. Here we can see AV, which is known as voltage gain, is equal to minus RC upon RE dash. Number two, RI, which is known as input resistance, is equal to, here we can see input resistance we will find across this input side there. So RI is equal to, it becomes R1 parallel R2 parallel beta RE dash. So here we can see R1 parallel R2 parallel beta RE dash. These three resistors are parallel with each other, and across it we can find Ri, that is input resistance. And finally we will find Ro, that means output resistance, which will be at the output side. So Ro, here we can see it becomes very easy because RC and RL, so both are parallel to each other. So RC parallel. Now next is CC amplifier. So this is the most amplification circuit. CC amplifier, that means common collector amplifier, and its another name is emitter follower. So why it is known as emitter follower? Because it follows the input signal. Whatever we apply in the input side, we will get same at the output side. Here input is provided at the base terminal, and we will get output at the emitter side. So that's why, due to output at the emitter side, it is known as emitter follower. So here we can see this is the circuit diagram of the CC amplifier. So in this circuit diagram, we will get output at the emitter side. So first we have to convert it into AC equivalent circuit. Here we can see this is the AC equivalent circuit with the help of pi model. So first we have to apply AC equivalent circuit. For AC equivalent circuit, we have to remove all capacitors in this main circuit diagram because it becomes shorted. Then and then we have to draw this AC equivalent circuit by using pi model, and instead of NPN transistor we have to put here pi model like this. So this is the CC amplifier, or we can say emitter follower, and which will provide us different types of characteristics value. Here AV, that means voltage gain, is equal to 1. Obviously this is the emitter follower, that means it follows the input signal, that means no gain present in this output side. That's why its gain, that means its gain is less than 1 or closely to 1, we can say. So here we will find AV is equal to 1. Now Ri, that means input resistance, and we will find input resistance across the input side. So its equation is like beta Re dash plus Re parallel R1 parallel R2. So this is the equation of Ri. So it is input resistance, and Ro, its equation is, and we will find Ro at the output side. So Ro is equal to Re parallel in bracket Re dash plus Rs parallel R1 parallel R2 upon beta. So this is the equation of output register. So that's all for amplification side. Till then, keep reading, keep learning. See you soon in next coming lecture. Thank you.